topic of today's class, but before I like to always have some quick review of last class. On the last class, we started to learn how to use graphing to solve linear equations. Good morning, Cynthia. And Mandy, no problem. As long as you open your assignment, you're good, okay? Open your assignment to have attendance, and then you are good. And we started on chapter 3, System of Linear Equations, and a quick review about solving system of linear equations by graphing. We started to apply these methods. When you have a linear equation, two equations with two different variables, and then you're going to graph, you're going to find the line that represent each one of the equations. If we're talking about linear equations, each equation is going to be represented by a straight line. And there are three different situations that you can find. The first situation is this one. Check this table. When you have one point of intersection. If you have the lines crossing in one point, like this, then you're going to have one unique solution. And this is the most usual situation, the most usual case that you're going to find. One unique solution for the system of equations. And how are we going to answer this? You have the lines crossing one point. You have x-axis, y-axis. And then you're going to answer with the coordinates of this point of intersection. Let's say the coordinate here on the x-axis is 2, on the y-axis is 3. The answer is the ordered pair 2, x equals 2, and y equals 3. This is how you answer a situation when you have one point of intersection and one unique solution. There's another possible situation, another case, where you're going to have parallel lines. If the lines are parallel, they have the same slope. They don't touch each other. They're not going to cross in one point. Parallel lines, they run side by side all the way to infinity. That means they're going to have no solution. Okay? The way we will answer on the quiz is like this. NS, that means no solution. But this is not a math code. The right way of answering it. And if you go to another class, if you go to another teacher, you have to answer like that. It's going to be an empty set, that means no solution, empty set, or something like this. Okay? This is only for our quiz. For our quiz, we're going to use this code here, NS, that means no solution. And the last situation, the third situation that you're going to find is this one, where you have infinitely many solutions. That means infinite solutions. When the lines are coinciding or coincident, one line on top of the other. They are in the same place, the same spot. They are actually the same line. And that means the intersection of one line is going to be all the points. The intersection with the one line with the other line is going to be all the points. All points are intersecting. To answer, you're going to write this, IS. This is our code for infinite solutions. Those are the three situations that we will find. And when you're graphing, you have to interpret, you have to identify what kind of situation you are looking at. And also on Tuesday, we learned how to find a solution of a system of linear equations like this. This is another example, but we have equation number 1, equation number 2, and they will intersect in one point. The way I've done this, the way we worked this on Tuesday was making, for equation number 1, we make x equals 0 and find y. Then you make y equals 0 and find x. And you're going to have 2 points, and with 2 points you can draw a line. You did the same thing for equation number 2, for the right one, x equals 0, find y, make y equals 0, find x, and the same thing, you have 2 points, you can draw a line. By 2 lines crossing in 1 point, you find the intersection, which is the solution. Real quickly, this is what we have done last Tuesday. Today we will do something kind of similar, but instead of making x equals 0, y equals 0, we will use the slope intersection form. The slope y-intercept form is like this. Y equals mx plus b. Remember, this is the slope, this is y-intercept. Instead of finding x and y, we will modify the equation and make it look like the slope-intercept form. So we can identify the slope and the y-intercept. Okay? Let's check. So the example that we're going to work today is the next slide. That's the example we're going to work today. We have a system of equation, and today we will check a system that has no solution. We're gonna find parallel lines. We don't know it yet. We have to calculate. We have to find out. So we have this system. We don't know yet the solution. Equation number 1, equation number 2. And what we will do, we will change each equation so they look like the slope-intercept form. Y equals mx plus b. So we can identify, you can check the slope m and the y-intercept b. Right? Let's start with equation number. Equation number 1 is negative x plus 3y equals negative 6. In order to change, to make it look like the slope-intercept form, we have to move everything to the right-hand side of the equation except y. We just keep y on the left-hand side, okay? Just keep y on the left-hand side and move everything else to the right-hand side. And the first thing you're going to move to the right-hand side is this x here. Let's add x on both sides, and then we will get rid of this x. We have just 3y equals x minus 6. Now divide both sides. I want to get rid of this 3. Divide both sides by 3. So divide both sides by 3, and then you're going to have, simplify, y equals 1 over 3 x minus 6 divided by 3, 2. Right? This is the equivalent of equation number 1, but using the slope-intercept form. Now let's work with equation number 2. Equation number 2 is 6y equals 2x plus 6. And divide both sides by 6, because we want to make it look like the slope-intercept form, right? So divide both sides by 6. And the result is going to be y equals 2 over 6 is the same thing as 1 over 3 times x. 6 divided by 6, 1. Okay, let me just 1. Now we have, and this is the equivalent of equation number 2 using the slope-intercept form. If I'm going too fast, if I'm talking nonsense here, if I'm not being clear, send me a feedback. Send a message on the chat box. Let me know if you have any complaints. If you're not understanding, let me know. What I'm going to do now, I'm going to graph these two equations using the coordinate system. And Kali is asking, so we are doing the same thing? We did yesterday with also labeling if the equation is infinite or has no solution. Yes, Kalia, is the same thing as we've done on Tuesday, but actually it's not. There's no difference at all. No difference at all. I'm just showing here a different way of calculating by hand. I suggest you work a few of the systems, of the questions of the quiz by hand, but it's up to you. It's up to you to work by hand, to use this method that I'm showing here, because you can do, using the graphic calculator, you can find the solution as well, the same way you done Tuesday, okay? It's the same thing. Let me graph this. I'm doing this by hand, and you can work using the graphic calculator, but it's also interesting to know how to do by hand, okay? And we're talking here about the first equation, y equals, okay, look at that. Y-intercept on the first equation is -2, right? This is the y-intercept. Let's find here -2 on the y-axis. Here -2, oops, -2. And the slope is going to be 1/3. This is the slope, 1/3. Is rise over run. Run is 3, and rise is 1. And we found 2 points. You can draw a straight line through these 2 points. Okay? And pretend this is a straight line. With this slope 1/3 and the y-intercept -2. Now let's draw the next one. Next is the red equation, the number 2 equation. And look at that, the slope is the same, 1/3, have the same slope, but y-intercept is a little bit different, it's +1. So check here where +1 is on the y-axis. +1 is here. And we're going to have the same slope. Run is 3 and rise is 1. So rise over run, 1/3. Draw a straight line. And this is the second equation. And have a look. This looks like the equations are parallel. The lines, actually, the lines of the equations, they are parallel. See? And if you're not sure, you check the slope. If they have the same slope, 1/3, 1/3. That means, yes, they are parallel. And when they are parallel, that means the system have no solution. Okay? Parallel lines, no solution. That's it. This is how you do by hand. You can work this out using the graphing calculator. I suggest you try a few of the questions on the quiz. You try to do by hand, but then you can always check. You can always go to the graphing calculator and check your work. Check if it's right. Thank you, Kalinga. I think we are ready to work on the quiz, and some of you have already finished, you finished the quiz, but not a problem. But first, I want to work a warm-up thing, a warm-up exercise here. Is this bell work? If 7 people meet and shake hands or bump fists with one another once, then how many handshakes or fist bumps will happen? And as I told you, it's a very simple problem. You need to work with multiplication and something else. There's a trick, there's a twist. Type. So 21 is going to be the right answer for the bell work. Each one is going to shake hands with 6, and but you have to multiply 7 times 6 and divide it by 2 and you find the right answer. The quiz is the same question as Tuesday. Solve each system of equations by graphing, find the solution, write the answer in interval notation. If there is no solution, write NS. If there are infinite solutions, write IS. So check the first one. We have the first one here is A equals h of x equals 2x plus 5, g of x equals negative x plus 2, and open your graphing calculator. And I'm suggesting you to use this online graphing calculator. GeoGebra is a free tool that you can access online. And on the first line, you type the equation. The equation here, you can type h of x, right? H of x equals the equation, or you can type y. That's the same thing. I'm gonna make with y because it's faster, but you can type h of x equals 2x plus 5, not a problem. You're gonna find the same answer. Y equals 2x plus 5. Enter. And y equals negative x plus 2. And then check the graph. You have an intersection. I like to change the color. Let's use this one is blue, this one is red, and the intersection is going to be here. Let's zoom in a little bit more. The intersection is, oops, this. X equals negative 1 and y equals x equals negative 1, y equals 3. This is the intersection, negative 1 and 3. Negative 1 and 3. This is going to be the answer. And if you want to check, you click here. Oops. Click here and it confirms negative 1 and 3. Okay? Right, Kalia? That's right. Okay, simple. The same thing that we have done on Tuesday. We're going to practice. It's really important that you do things understanding what you're doing, not just typing and finding and copying the answer. Try to understand what's happening. Try to look at the graph, analyze, interpret the graph a little bit. Understand that where is the x coordinates. Check on the y and the x-axis, the x coordinate. Check on the y-axis, the y coordinates. Okay. Try to do each question, work each one, understanding, not just typing and finding the answers, but understand what you're doing. That's it.